Hey everyone! Today we are going to start using what we've been learning about quadratics when it comes to graphing them and factoring them, and we are going to start applying them to solving quadratic functions. And so we're going to look at several different methods today. The first one we're going to look at is graphing. And when we can say that we can solve by graphing, because if you think about when we did graphing systems of equations, our answer was the point where the lines crossed. So similarly, when we graph a parabola, our solution is going to be the point where the parabola crosses the x-axis, because we're saying what is the value of x when y is 0? That is going to be our solution to a quadratic function. So we're going to solve this one by factoring. There we go. That's better. All right. So what we're going to do, since this is in standard form, we are going to find our vertex. X equals negative b over 2a. This would give me negative 3/2 for my x-coordinate. And that means my axis of symmetry is x equals negative 3/2. So that's going to be here. There we go. Now, I want to find my y-coordinate next so that I can find the vertex in its completion. And I'm going to put y equals negative 3/2 squared plus 3 times negative 3/2 minus 1. This would give me 9/4 minus 9/2 and then minus 1, but I want everything to have a denominator of 4. So I'm multiplying this one here by 2 and this one by 4. That gives me 9 over 4 minus 18 over 4 and minus 4 over 4. When I do 9 minus 18, I get negative 9. And negative 9 minus 4 is negative 13. So we get negative 13 over 4, and that's our y-coordinate of the vertex. So our vertex in its entirety is this. Negative 13 over 4 is like negative 4.25, I think it is. So I'm going to go a little bit past negative 4, and it's going to go right here. All right, now I know what my y-intercept is. My y-intercept is what? Negative 1. It's the number at the end. So I can graph this point, and I can graph its reflection. But I still need one more point, and so I'm going to pick x equals negative 1. And when I do that, I get negative 1 squared plus 3 times negative 1, and then minus 1. So this gives me 1 minus 3 minus 1, which would be negative 2 minus 3 is negative 3. So I'm going to graph the point negative 1, negative 3. Something's not quite looking right. Oh, I know what I did. Negative 13 over 4 would be negative 3 point something. Sorry about that. So that would go here, and that makes way more sense. All right, so when I connect those points, I'm going to get a parabola that looks like this. So that would be graphing, but then to solve it, I would have to say, okay, where does it cross the x-axis? It crosses right here and right here. What are those points? Take your best guess. Looks like this one is somewhere around 1/2 0. This one looks like it's at like negative 3.10. So I would estimate that x is approximately, that's what the squiggly equal sign means, approximately 1/2 and negative 3.1. If I look at it on a graph, on a computer graph, the actual correct answer is not that far off. It's like negative 3.3, I think, and positive 0.6. But does this help you kind of see what is a benefit of graphing and what is a con or drawback of graphing? I would say that the benefit here is that you can see what your answer is. You can see the solution. But just like with graphing systems of equations, I cannot, sometimes I'm going to get like an inaccurate answer because it's not crossing directly at a certain point. So those are kind of some of the things to think about. But we're going to look now at factoring. Graphing is good, but factoring is better. So some key terms that, or not terms, key things to remember. The quadratic must be equal to 0. It has to equal 0, otherwise we can't factor. We're going to factor the expression and then apply the zero product property. We learned about this at the beginning of the year. It just says that if you have two numbers being multiplied together or two things being multiplied together and your answer is 0, one of those things has to equal 0. So the first thing I'm going to do is get everything on the same side. That gives me x squared plus 7x minus 18. All right, now I'm going to factor this just like we've been doing up till now. And I'm going to split up my x's. What multiplies to 18 subtracts to 7. 9 and 2. Same sign or different? And this one goes with they're different signs, and the positive goes with the bigger number. Now, if we were factoring, we'd be done, but we are solving. So now what I'm going to do is I'm going to write each set of parentheses set equal to 0. I'm going to get x plus 9 equals 0 and x minus 2 equal to 0. This gives me x equals negative 9, x equals 2. And so this tells me that if I plug in negative 9 to this equation right here, I will get 0. If I plug in 2, I will get 0. And I can check that because negative 9 here would make this set of parentheses equal to 0. It doesn't matter what's over here. 0 times anything is 0. And so that's what the zero product property is. And you should get 2 answers most of the time. All right, so if I bring the 6 over, I get 2x squared plus 4x minus 6 equals 0. What do you think the first thing we need to do with this problem is? Hopefully you said GCF, because if I look at these numbers, they are all divisible by 2. And when I take out that GCF, now I've got the rest of this. So I've got 2 and then x, 3 and 1. This means they're going to be different, and this goes with the bigger number. Okay. So I need to set each factor equal to 0. I don't need to do anything with this 2 in front because if I set it equal to 0, it would just be not true. However, if I end up with a GCF that has a variable in it, then I will need to worry about it. And we'll look at an example like that. Here, if I subtract 3 from both sides, I'm going to get x equals negative 3. I'd add 1 here, add 1, and x would equal 1. So my two answers would be x equals negative 3 and x equals 1. If you wanted to check these, you could simply take the answers that you got and plug them back in to make sure that you get a true statement. For example, if I plug in 1, I would get 1 squared, 1. 2 plus 4 is 6. That's a true statement, so this one would work. All right, here I'm going to get everything on the same side. So I always try to leave x squared as a positive number, and so I'm just going to leave it there and move the 8x. That's how I decide which one I'm moving. It doesn't matter which side the 0's on, which side the x squared is on. So I'm going to get 16x squared minus 8x equals 0. And now if I look for a GCF, what am I going to get? My GCF this time is going to be 8x, because both can be divided by 8 and they both have an x. So when I divide by 8x, I'm left with 2x minus 1. Now, because this GCF does have a variable with it, I'm going to set that equal to 0. In this one, I'm going to also set equal to 0. Here I would just divide by 8 and I would get that x equals 0. That's one of my answers. My other answer is that I add 1 and I get 2x equals 1, divide by 2, and x equals 1/2. So factoring is probably the preferred method for most people for solving because factoring just is pretty easy, I think, at this point for people. Not always, but usually. And they like this method better than some of the others. The downside is it's not going to work for every single problem we encounter. But there is another method we can look at. We have some special cases. Sometimes there's going to be problems that look like this, and there's no x term. Now we know how to factor that, but there's a shortcut. We're going to solve for x squared and then take the square root of both sides. So here's what it looks like. I'm going to get the 25 on the other side, and I do 4x squared equals 25. Divide both sides by 4. X squared equals, and when I take the square root of this, it looks intimidating to take the square root of a fraction, but you can do this without a calculator. The square root of 25 is 5, or sorry, I should leave it 25 over 4 first, and then show the square root. There we go. The square root of 25 is 5, and the square root of 4 is 4. But here's the catch. You cannot just put 5/4 because that is not the only answer that makes this true. When you take the square root of something, you get both a positive and a negative. So you have to put a plus or minus. We need two answers. You can also think of it as writing it this way. My answers are 5/4 and negative 5/4. But you have to remember that it's two answers. You could also factor this into like 2x plus 5, 2x minus 5. But I think that this is a faster way to do it. So let's try this one. I see that there's no x, just an x squared. So I am going to add 9 over 49 to both sides. And I'm going to get x squared equals 9 over 49. When I take the square root of both sides, I get x equals plus or minus 3 over 7. And that's it. So there you have it. Those are the three methods that we're going to start with. Graphing, solving by factoring, solving by taking the square roots. Each have their pros, each have their drawbacks, but that is just kind of an introduction, and we'll practice this some more. If you have any questions or are not sure about something, make a note of it, write it down, send me an email, or just ask me in class. Thanks, guys.